Okay, in this video we're going to look at how to find slope, or really identify slope, in a word problem. So again, everything in the bubble is review. Slope is still how quickly the line or pattern is changing, no matter which form the line is given in, table, graph, points, word problem, no matter what. If it asks us to find the slope, it's asking us to figure out how quickly is this particular pattern or line changing. So we still need our delta y and our delta x, and slope is still delta y divided by delta x. Okay, it's how many whatever are we adding or subtracting is our delta y, and our delta x is how often. Okay, so in our first word problem, it says Marcus was in a tricycle race. He got a 3-meter, it's supposed to say head start. And pedals 5 meters every 4 seconds. Okay, so take a moment to press pause and copy this down, then let's work through it together. Okay, so we just need to figure out how to find this slope. Okay, so we still need our delta y and our delta x. We just have to figure out in this word problem, in this situation, what is our delta y and what is our delta x. Well, our delta y is really what's changing. Okay, it's a speed, so we want to know how fast he's going. This is a tricycle race, so we want to know, well, what is his rate of change? How fast is he pedaling? Well, it says he's pedaling 5 meters every 4 seconds, so the delta y is 5. Okay, and this means he goes 5 meters. Okay, and now we need to figure out, well, what is our delta x? Well, how frequently or how often is he going those 5 meters? So the delta x is simply our 4 seconds. He's going 5 meters every 4 seconds. And this is exactly what it says in the word problem. He pedals 5 meters every 4 seconds. The delta y equals 5. The delta x equals 4. He goes 5 meters every 4 seconds. So our slope is our delta y over our delta x. And again, like always, we leave it as an improper fraction because this makes it easy to understand. He traveled 5 meters every 4 seconds. That's what a slope of 5/4 is. So again, we just want to identify in the problem, what do we need? We need our delta y and our delta x still. Our delta y is he goes 5 meters, and our delta x is how often. Well, he does that every 4 seconds. So the slope is simply 5 meters every 4 seconds, so it's 5/4. Okay, next example. Suzanne has $134 on her lunch card, and she spends $12 every 5 days. So we will still want to figure out what the slope is, and the slope is still the rate of change of this situation. So in this problem, it's going to be how quickly does she spend money. So we need to identify our delta y and our delta x. Well, our delta y is that she spends $12. That's what this says. She spends $12 every 5 days. So she's spending $12. Now, since she's spending money, she's losing money. So that delta y has to be negative. This situation is decreasing. Okay, her lunch money is decreasing, so our delta y is negative. She spends $12. And our delta x is how frequently does she spend those $12? Well, she spends those $12 every 5 days. So our slope is still delta y over delta x, so our slope is negative 12/5. Okay, she spends $12 every 5 days. That's exactly what it says in the problem. So she spends $12 every 5 days, so our slope is negative 12/5. Yeah, this is pretty easy. Once we understand that slope is really just the rate of change, it's the speed that our situation is changing. And once we understand our delta y is how much are we adding or subtracting, and our delta x is how often, it's very easy to identify the pieces that we need in a word problem. So in this case, this $134, this is our starting amount. To figure out the slope, we didn't need it. The only thing we need for the slope is the rate of change. So for this, that 134 was unnecessary. Okay, it's useful in other situations, but in this, when we're just finding slope, the only thing we need is the rate at which she's spending her money. Okay, our next example, let's just look at this one. A tree was planted when it was 1.5 feet tall. Okay, every 3 years, it grows 6 feet. So take a moment to copy it down. So we need to figure out the slope still. For all these problems, we're finding the slope. So we need to figure out what's our delta y and what's our delta x. Well, how much is the tree growing? That's what our delta y is. How much are we adding or subtracting to the tree's height? Okay, so it says every 3 years it grows 6 feet. So this growing 6 feet is our delta y. So our delta y is 6. It grows 6 feet. Okay, so we just have to figure out, remember, delta y is just how much are we adding or subtracting. It's not really the first number we see in our rate, it's how much are we adding or subtracting. So just take a moment, understand the situation. The tree grows 6 feet. So that's what our delta y is, and then our delta x is, well, how often does the tree grow 6 feet? Well, it grows 6 feet every 3 years. And this is our rate. The tree grows 6 feet every 3 years, so our slope is 6 feet over our 3 years, and we notice that 6 over 3 reduces to 2. So if it grows 6 feet every 3 years, it's the same as growing 2 feet every year. Okay, and that's what our slope of 2 represents. Okay, our next problem. Cleo weighed 126 pounds 5 days into her diet. 9 days into her diet, she weighed 124 pounds. She continues losing weight at the same rate. Now this one's a little bit different. Okay, it doesn't really give us the specific rate of change directly. Okay, but it does give us enough information to figure this out. We still need to know what's our delta y. How much pounds is she losing? She's on a diet, so she's going to be losing weight. So we want to know how many pounds is she losing. That's what our delta y is going to be. And our delta x is how often. Is she losing that amount of weight every day, every 2 days, every 3 days? How often is she losing weight? So we notice that she weighs 126 pounds 5 days into her diet, and 9 days into her diet, she weighs 124 pounds. So I'm going to use this information to make myself a little table. Okay, my x is the days, my y is her weight. So 5 days into her diet, she weighed 126 pounds. 9 days into her diet, she weighed 124 pounds. Again, we like tables. Tables are a nice, easy way to organize our work, because the only thing we need right now is, well, how much weight is she losing? Well, she's going from 126 pounds to 124 pounds. So she's losing 2 pounds. Our delta y is negative 2. She's losing 2 pounds. We're subtracting 2 from her weight. So she's losing 2 pounds. Okay, we can get that directly from the word problem if it helps make a little table, and then figure out she's losing 2 pounds, but she goes from 126 pounds to 124 pounds. So our delta y is she's losing 2 pounds. We're subtracting 2 from her weight, and our delta x was how often is she losing those 2 pounds. Well, she's going from 5 days to 9 days. We're going from 5 to 9 in our x's, so she's losing those 2 pounds every 4 days. Like I say all the time, once we understand that slope is really just the speed at which something's changing, the speed at which this line's changing, it's very easy to pick out what we need in the problem and just ask ourselves those questions. How much weight is she losing, and how often is she losing that amount of weight? So we identify she's going from 126 pounds to 124 pounds, so our delta y is negative 2 because she's losing 2 pounds. Now, how often is she losing those 2 pounds? Well, she's going from day 5 to day 9, so that's every 4 days she loses those 2 pounds. So our slope is losing 2 pounds every 4 days, negative 2 over 4, and this reduces to negative 1/2. So she loses 1 pound every 2 days. Okay, and last one. A bunny weighed 7 pounds when it was born. 3 weeks later, the bunny weighed 8 pounds. The bunny continues gaining weight at the same rate. So apparently this is a freakishly large bunny, but no matter. We still want to figure out what is the slope. How quickly is this bunny gaining weight? So pause it, copy it down, even try it on your own, then press play when you're ready. So again, the things we need are our delta y and our delta x. Our delta y is how much weight is this bunny gaining? How much are we adding to this bunny's weight? And our delta x is, well, how frequently is that bunny gaining that amount of weight? So since it doesn't give it to us directly, I'm going to make myself a little table. Well, the bunny weighed 7 pounds when it was born. That means when it was born, when x equals 0, the bunny was 7 pounds. Then it says 3 weeks later, the bunny weighed 8 pounds. So after 3 weeks, the bunny weighs 8 pounds. So that means our delta y is how much weight did the bunny gain? Well, the bunny gained 1 pound. So the bunny gained 1 pound. And how much time did it take for the bunny to gain that 1 pound? Well, the bunny gains that 1 pound in 3 weeks. So the delta x equals 3. So the bunny is gaining 1 pound every 3 weeks. So our slope is 1/3. Okay, great. So if you need more examples like this, there's a lot of examples of word problems in the textbook or on the online resources.